The Eclipse. Okay, so we create a project for this week. That'll be week 14, I believe. Yeah. New Java projects. CSE114, S16, week 14. And then Lab1. Okay. And then, first of all, let's create a polygon class. Okay, polygon. And if you like, you can also choose abstract over here because we're going to make it abstract. But what it does is it's going to add the abstract in front of the class. So you can also type it out manually if you like. Okay, abstract class here, polygon. Okay, let's see what we have. First of all, you can say a polygon may be a triangle, a rectangle, and etc. Okay, maybe anything. So now let's say we simply define an attribute here, which is going to be an array of double. Just call it sides. Oh, sorry, like that. So you can say we represent a polygon as an array of sides. Okay, that'll be enough. In the case of a triangle, the size of sides is 3. In the case of a rectangle, the size of sides is 4. Yeah, let me say length. That may be more appropriate rather than size. Okay, so the size might be the length might be different depending on what kind of polygon you're talking about. Okay, so now let's say this. So now we define a comment mutator which will be inherited to all subclasses. So which means all the like triangle, rectangle, they're gonna share the same. Okay, let's say void grow. Let's say this one here simply growed each sides by 1 unit, let's say. As simple as that. So you can say grow the sides, grow each side of the polygon by 1 unit. Why don't you try without looking at the slides? How would you do that? So basically, you just have to walk through, iterate through the array of sides, and then just increment each value. This one should be very easy to do. Why don't you take 1 minute or 2 to do that? This one should be very easy. Okay. Okay, when you're done, you can have a look at the projector here. That should be what you get. Of course, you might say size I equals size I plus 1. Well, we can use the plus plus notation. Okay. So this one's very easy. Okay, so now after this, we're going to define a common accessor. We define a common accessor which will be inherited to all subclasses as well. So let's say this accessor here, we're going to get the parameter. Okay, let's say double, since the each side is a double. Get parameter. Okay, I help you a little bit, and I'll let you do the rest. Let's say double parameter initially just 0, and then eventually you want to return that value. But how do you accumulate that? By each side. Okay, I'll let you do the rest. Return the sum of sides. Okay, let's see how you can do that. That should be very simple. Okay, so when you're done, you can have a look. That should be what you would get. Okay, so now, what about get area? As we said today, at this level, for the polygon, you simply don't know what kind of polygon you may have. You may have a polygon with 3 sides, 4 sides, 5, 6. You simply don't know. As we do not know the exact number of sides of the polygon, so you can be, for example, it can be a triangle, it can be a rectangle. Okay, I'm not sure how you spell that. Yeah, what? How do you spell the polygon with 10 sides? Octagon, right? OCT. Sorry, I'm very bad in spelling. Sorry, let me look it up very quickly. I have to Google it. Oh, octagon. Oh, that's right? Well, I was right. Somehow Eclipse doesn't recognize that. Okay, that's fine. Okay, I was right. Octagon, etc. But that's my point. You simply don't know at this level here. As we do not know, we leave the get area method unimplemented. This makes the polygon class abstract. Remember the definition of an abstract class, which means at least one method is unimplemented. So in this case, we're going to say, first of all, we use a keyword abstract. And then the get area is supposed to return a double and get area. Okay. Let's now try a tester right away. Okay. So let's now, you can see also in Eclipse, you can see something like an A around the icon there. So that means it's abstract. Okay, let's now create a class called polygon tester. Okay, with a main method there. Let's try, let's see what we can do. So let's say this. Polygon P. So this is okay, which means we're declaring a variable P of static type polygon. However, if we try this, equals new polygon. This is not okay. Okay, let's see what the Eclipse says. Cannot instantiate a type polygon. Okay, because polygon is actually an abstract class. Okay, let me just write a reason here. Since polygon is an abstract class, meaning that at least one method is not implemented there. In this case, the get area method, since it has at least one method that's unimplemented, we cannot use polygon as the dynamic type. Remember what I said in the class. Let's say if we did allow this, and later on if you say p.getArea, it was simply undefined, right? Simply undefined because the get area method is simply not defined in the polygon class. It's abstract. So that's why this line should not compile. So if I ask you this question, let's say later on in the quiz, what the exam, what you should say is, declaring a variable of abstract type, abstract class type is okay as a static type. However, if you try to use that as a dynamic type, it's not good. Okay? It's not appropriate. Okay, so let's comment this out. Okay, so now let's try to see what kind of classes we can have to implement, which will implement the polygon. So now let's go back to Project Explorer here. Let's create a new class. Let's do the simple ones first. Let's say rectangle. Rectangle. So now for the superclass over here, you can browse. Over here, you can see by default, it's simply the object class, right? That's the implicit. So now you can type polygon. You will see that's under your project over here. If you see polygon, okay? And then you can say finish. You can see somehow Eclipse does something for you. You can see because rectangle here is just a normal class without any abstract over there. So by default, Eclipse generates some code for you, assuming that you're actually going to implement the get area method. So for now, it simply returns 0 for you. But that's not the right implementation, of course. So we're going to do something about it. Okay. So now let's write some comments here. A rectangle is a special case of, let's say a specialized version. A specialized version of polygon. There are 4 sides. Okay, so now let's see what we can do. So now we're going to define a constructor here. So now we can say rectangle. So now because for the rectangle we know we're going to have the width and length. So we can say double width and double length. And one thing to note that since rectangle extends, let's say inherits, extends is fine, extends polygon, it inherits the, remember in the polygon we actually got this attributes here, right? So that one will be inherited. So it inherits the attributes. Okay, that's something to note. So that means implicitly we actually have the sides available here in the rectangle class. And now we're going to see that in the constructor over here. Now that we are being passed width and length, let's see how we can initialize the sides over here. Okay. So now let's simply just go back to polygon first. Okay. Let's see what we can do there. So polygon here. So here you can say polygon. You can still define a constructor, just that you cannot use it. But we can just actually use the reuse the code later for the subclasses. So now we can say polygon here. So we're gonna pass an array sides. This dot sides equals sides. Yeah. So now let's go to the rectangle. Over here, so somehow we're going to create an array. Let me just write a slightly more comprehensive version for you. Let's say double sides for rectangle. Okay. So it's going to be of size 4. Like that. Okay. And now we're going to say sides for, so this is slightly different from your slides, but they're doing the same thing. So now let's say here, so you got 2 versions. Let me show you version 1. 0 will be the width, and sides for rectangle. Let me just be a little bit lazy here. You got 4 assignments here, 0, 1, 2, and 3. So width, length, width, length. Okay, over here. That's one way to do it. And then we have to call the super constructor. Okay. So let's say you might think you can simply say super, so which means we are trying to call the constructor over here. Okay, super, and then we say sides for rectangle. But somehow this wouldn't compile. Okay, let's see why. It says that the constructor call must be the first statement in a constructor. So which means whenever you want to use a super, you want to use the version of constructor from the superclass in Java, it has to be the first line. It has to be, somehow. However, if you try to do this in the first line, but the problem is, if you try to use sides for a rectangle, it's not being declared yet, because it's only declared in the second line. That's kind of weird. So that's why in the slides I show you the version that works. Okay, so let me show you how the version that works. Okay, you can comment this out to actually just remind yourself. Okay, so now remember that super has to be the first line. I wouldn't test you this on the exam, but if you later on program in Java, that's actually something to note. If you want to call the constructor from the superclass, it has to be the first line. So that's why you have to write your code in such a way that you have to be careful. Okay. Let me show you the version that works, which is on the slides. The version that works is if you say super here, and then we can now simply do. Remember I talked about anonymous objects in the class. So you can say new, and then double array 4. Okay, so this means I'm creating a new array objects without giving that a name. Okay, so typically, when you do the array, you will say something like this. So let's say if I have double, I'll say double array, DA, equal to new, and then double size 4. Okay. So basically what this does is it's going to create a new array and then give it a name called DA. But now in this case, we simply just pass this expression here directly as the arguments, rather than giving that a name and pass DA. So it's different. Okay? Because if you try to do this, if you say super and then DA, this is not going to work because super has to be the first line of the method. So that's why we're using this workaround. Okay. So I just learned that I wouldn't test you on this on the exam. It's a little too subtle. Okay, let's say this. We do super that. So now so once we have done that, so you can see in the polygon, we have assigned the sides to be this array here. So now what should we do? So let's do this. So now you can say sides 0 is equal to width. Sides 1 length, sides 2, sides 3. Okay, this version will work. Which means we try to call the call the version of the superclass for the constructor. And then we initialize each side one by one. 0, 1, 2, 3. Okay. So that's the rectangle. So now let's see how we can get the area. So now one thing to note, the get parameter and grow methods are inherited from polygon. We do not override them. Okay? We keep them the same. Only the get area we're going to override it. So now how do we override it? So you can simply say we're going to return so sides 0 multiplied by sides 1. Or you can say sides 2 multiplied by sides 3. Doesn't matter. Okay, just two sides. Make sure you do the width and length. Okay. Okay, let's try this in a tester. So if you say polygon P, new, rectangle 2 and 3. Let's say 3 and 4. Okay, so now if you say system dot L dot print line P dot get parameter system dot L dot print line P dot get area. Let's see what we're gonna have. So apparently you're gonna have 3 plus 4 multiplied by 2, 14, and then 3 times 4, 12. Okay, let me just put some rectangle parameter. Rectangle area. Okay, let's say we do that. You can see the parameter is 14 and the area is 12. Okay, let me ask you this. If I say the following, if I say system.out dot print line, okay, polygon is a rectangle. So what do I mean? If I say, let me just change it to a new line. Okay, let's say this is a print. So now system.out dot print line. Remember the instance of we learned. If I say P instance of, so rectangle. Now we are really asking if the dynamic type of P is a descendant class of rectangle. It is, because the dynamic type is rectangle. Rectangle is a descendant class of rectangle. Okay, so that's going to be true. If I try that over here, it's going to be true. If I try another one, what about, oh, sorry. Let's copy these two lines actually. So polygon is a polygon. So P instance of polygon. Okay. So now the dynamic type still is simply rectangle. Is rectangle a descendant class of polygon? It is. So it's going to be true as well. Okay. So now basically we are saying that so here we got polygon here, and we have rectangle. So now the dynamic type is actually rectangle. So we are asking if rectangle is an instance of rectangle. It is. And also if rectangle is an instance of polygon. It is as well. Because rectangle is a descendant class of itself and also a descendant class of polygon. Okay, that's why. If you look back to the notes for instance of, you'll see that rule. Okay, so now let's say we try to grow the rectangle a little bit. Let's say system.out.println grow the rectangle. So now we'd say p.grow. Okay. So now I would like to repeat to print out the parameter, to print out the parameter and also the area, like that. Okay, you can see it's exactly the same method calls, but now since we said p.grow in line number 18, so the parameter and the area is going to change because the size will change as well. Right? So it used to be 3 and 4, so now it'll be 4 and 5. Okay, so it's going to be 18 and 20, right? Let's see that. Yep, you can see now it's 18 and 20. It used to be 14 and 12 before we grow it. Okay, let's just see the debugger and see how that works. Okay, and then for the triangle, it'll be rather easy. Put a breakpoint over here. Let's say we say run debug as Java application. Okay, let me see this. Oops. Okay, let's see here. So now let's step into it. So if you say, where is my step into? Somehow it's gone. Let's see. Can I say debug?
Because you're using the F5 key.
Sure, I would like to. Let's step into?
Yeah, I think so.
Actually, somehow I didn't have it set it up properly. But I remember there was one I can do from here. Give me a moment. Maybe I just need the debug window. Window, show view, and then debug. Okay, there we go. Okay, just need a debug window here. Okay, but thanks anyway. So now let's step into it. So now we are in the constructor of rectangle. Okay, you can see in the constructor of rectangle there, we try to call super. And super here refers to the polygon. And we are trying to initialize the sides into an array of size 4. So let's step into again. So now we are in the polygon constructor, right? And now you can see the sides over there is simply an array of size 4. Okay? And then we try to assign the sides to be this array. You can see the sides now is simply just this array over here. Sides over here. Okay? Okay, and now you can see that for this particular rectangle here, you can see the sides has been initialized to be an array of size 4. Okay? 0 for each. And then you can see the width is 3 and the length is 4. So we're going to assign them one by one. Eventually, you'll see that the sides here is 3, 4, 3, 4. Okay, okay, that's what this line is doing. Okay, I think that line is the most important line, just to show you how the rectangle has been created. Okay, any questions up to now? No? Okay, good. So that's about the rectangle. Let's go move on to triangle. Let's create a new class. New class triangle. And superclass, you can just type, say polygon. Okay. Finish. Okay, we just have to define a constructor here, which will be very similar to the case of rectangle. Let's see how we can do that. Okay, for triangle, we're gonna do also a constructor here. Triangle. In this case, we have 3 sides, so you can say double S1 for side 1. Okay. Double S2, double S3. Okay, so that we're going to do similar thing, but now we say super, but now we're going to create an array of size 3 rather than 4. So you'll say new double array of size 3. And now we can do sides at index 0 is assigned to S1, sides at index 1 is assigned to S2, and then sides at position 2 is assigned to S3. Okay, that's it. Okay, and similarly, we actually inherit the get parameter and grow from the polygon class, which we don't intend to override in this class. We only intend to override the getArea method here. So now we can say apply the Heron's formula, okay, which is, let me just show you again. That's what we learned from today. And then I'm going to show you on the slides, and then you can see, try to do this yourself to see how you can use the math class square root. to do that quickly. Okay, I'll show you now. Okay, that's the formula. Okay, why don't you take about 2 to 3 minutes to see how you can put this into Java. So given the 3 sites, A, B, and C, so in this case that'll be sites 0, sites 1, and sites 2, right, at different indices. And then you have to calculate S. And S would simply be the parameter divided by 2. Okay, and then you're going to do this multiplication here and then take the square root. Okay. I'll let you do that to see how you can translate it to Java. And for the square root, you can just use math, SQRT. Right, math SQRT for square root of something. Okay, another minute, and then I'll do on the screen. Okay, let's see. Okay, let's say this. First of all, let me just say A, just to correspond more to the formula. A would be the first site, sites 0, double B, sites 1, double C, 2. And then double S would be A plus B plus C divided by 2. Either you can say that, or you can say get parameter divided by 2. You can also do that. Get parameter basically is doing A plus B plus C, right? Or if you really like, you certainly can say A plus B plus C. Either version will work. The version on the slide simply just copy get parameter, but you can try this version as well. Okay, and then we can now apply the formula to say double area is assigned to math dot square root S multiplied by S minus A, S minus B, S minus C. And then eventually you're going to say return the area. Yeah, that's how you do it. Of course, here the A, B, and C are not really necessary. You can simply say size 0, size 1, size 2. It's up to you. Just kind of neater is how I do that. Okay, so let's try this. Let's go back to polygon tester here. So now, because the triangle is a ordinary class, it's not abstract. So we can say P is assigned to new triangle. 3 sides, 3, 4, and 5, for example. Okay. So now we can say system.out.println. So triangle parameter plus p dot get parameter system.out.println triangle area plus p dot get area, like that. let's see the output first. Okay, it should be should be 12 and 6, I believe. Yep. So the formula works for this particular example, but it's a formula, so you can assume it works. Okay, I would like to draw your attention to 2 lines. So now you want to compare this line here, line number 20, and line number 24. So these 2 lines, we are trying to make the same method called p.getArea. But somehow, it's going to have different effects, apparently, because P's dynamic type in line number 20 is different from P's dynamic type in line number 24, right? Because we know in line number 20 is actually a rectangle. In line number 24, it's a triangle. Let's double check with that in the debugger. Okay. So now, if we put a breakpoint over here in line number 20, let's have a look. Now, if you say run debug as Java application. So now we're here. So now, because the dynamic type is rectangle, if you say step into, so now we are in the get area. Oh, not yet. Okay, just skip this. I'll step into. So now we are in the get area method in rectangle. So that's the version that's being called due to dynamic binding. Okay. After this, so now let's go on to this line number 24. So here we are trying to say p.getArea again, but now because the dynamic type has been changed by line number 22 into triangle. So now if you say step into, let's just skip the string builder here. And now if you say step into, you see that we are now in the getArea method, a different version that's in triangle. Okay, that's exactly what dynamic binding is about. Okay, something to show you on the machine rather than just on the board. Okay, any questions up to now about? So now we actually have got polygon, and we got 2 subclasses, rectangle, and we have triangle. Remember, polygon is abstract, and rectangle and triangle, they are simply the increments every method from polygon. Okay. So now let's introduce the polygon collector and polygon constructor that we also talk about in the lecture today. Okay, let's see how they play out. So now let's do this. Let's go to Project Explorer here. Can we create a new class over here called that polygon collector? Okay. For the polygon collector here, let's see. Okay, for that one, we're gonna have an array of polygon. So over here, you can say we declare an array whose each element has the static type polygon. Due to polymorphism, the dynamic type of each element can be any of the descendant classes of polygon, i.e. triangle and rectangle. We'll see that. So you can add either a triangle into the collector, or you can add a rectangle into the collector. Okay, that's something to note. Okay, and we also have a counter over here. Integer, let's say the number of polygons. Number of polygons. Yeah, basically what we did before, just about how you can maintain a collection. So let's say we have a constructor here, polygon collector. Okay, And we simply just initialize the polygons array to be a new polygon array of size 10, let's say. And remember what we said on Friday. So here, if I say void add polygon, let me just do this one first. And then I can say polygon here, P. And we can say polygons at position number of polygons equals P. And then the number of polygons plus plus. Okay, so now let's try to see another two versions of the method. We can also say add rectangle R. So now we can say polygons. The number of polygons is assigned to R. It compiles, right? Think about why it compiles. The number of polygons plus plus. Okay, let's do one more. Okay, let's say here, void add triangle T. So polygons, the number of polygons assigned to T, the number of polygons plus plus. Now I want you to focus on line number 16, 21, and 26. So let me put it here. Questions. Why lines? Of course, in your case, it might be a different line, but I'm talking about this line here. Lines 16. Also lines 21 and 26. Why do they compile? Think about it, and I would like to hear from you why they compile. It's actually from the lecture of Friday, which will be covered on this Friday, so you better think about it. Apparently, you can see we got three methods here, and the parameter type are different. In the first one is simply polygon. And the second one is rectangle. And the third one is triangle. Okay. Yeah, think about why they compile. Over here. It's actually quite important. Think about it for a minute, and then we can discuss. Remember, if you want to decide if one line should compile or not, you should look at the static type. Right? Static types only. Let's start with line number 16. Why does line number 16 compile? Okay, point to someone. Why? That's right. You're lost. Okay, that's fine. That's fine. That's fine. Let's try. Line number 16. Think about the static type. Let me help you. Let's do step by step. So line number 16, we're trying to assign P into polygons at position number of polygons, right? So what's the static type of P? Polygon? How did you know? So where did we declare the static type of P? So, or where do we declare P? Exactly, yeah, exactly. So in line number 15, we say P is of type polygon, right? So we know that the static type of P is polygon. So now, what about the left-hand side? What's the static type of polygons at position number of polygons? How did you know? So where should we go? You know, you're going to find out, so what's the declaration for polygons then? So somehow we need to go to this declaration, right? So I believe that's somewhere above. Tell me the line number where we define polygons. Number number 8, yeah, in my screen, right? So here we're saying that polygons is simply an array of polygons. So each element has a static type polygon. Okay, so now we sort out the left-hand side and right-hand side static type. So now you can see that over here. So that's the line we were talking about. So we know that P is of static type polygon. And polygons at number of polygons is polygon. So now we're asking the question, is polygon a descending class of polygon? Yes or no? Is polygon a descending class of polygon? It is, right? Because a class is simply a descending class of itself. So that's why this line compiles. Can you follow? Okay, good. So we follow the same reasoning steps for line number 21. So now you can see the polygons at number of polygons, the static type remains the same, just polygon. So what about R? Yeah? How did you know? Which line? 20 exactly. That's where we clear that. So now we're asking the question, is a rectangle a descending class of polygon? It is. So that's why that line compiles. Okay, finally, we know that in line number 26, T static type, as we know from this line here, is triangle. And triangle is a descending class of polygon. So that's why that line also compiles. Okay, very good. So let's try something here. Let's now go to, okay, let me just write it down for you. Line number 16. Static type of P is polygon. Static type of polygons at position number of polygons is polygon as well. Polygon is a descending class of itself. Okay, let's do one more. Line 21. Static type of R is rectangle. And the static type of that remains the same. Let me just copy that. Okay, the same. So now we know that rectangle is a descending class of polygon. And for line number 26, you can follow the same reasoning because triangle is also a descending class of polygon. Okay, you should really know why it actually compiles. Very important. Okay, let's try this in the tester. Okay, let's try that. Why don't we try this one here? Can we just go back to tester here? Okay. Let me do this first. Let's say we have rectangle and R equals new rectangle. Let's say 3 and 4, just make it easy. And let's have another triangle T assigned to new triangle. Let's say 3, 4, and 5. Okay, so now let's say we create a new rectangle, new polygon collector. Polygon collector, let's say PC. Okay, new polygon collector. So now let me try this one here. If I say PC dot add rectangle, if I say T, okay, this one does not compile. You see? It says that somehow, wow, the method add rectangle, which takes a rectangle, is not applicable for the arguments triangle. So what does that really mean? So here. So again, this is a review from lecture on Friday. Okay. So let's see why it is the case. Okay. I'll just explain one more time. So now over here we say Again, to see if that compiles or not, you have to see the static type. So let's put all the relevant information on the board. So first of all, we got T here. So this is how we declare T. We say triangle T equals something here. Okay, it doesn't matter. We just want to know the static type. And then we say PC dot add triangle. And then T. Okay. So we know that the PC here the static type is polygon collector. And in the polygon collector class, we do have a method called add triangle. Okay? So now if you go to the add triangle method there, so polygon collector here, if you go to the add triangle method there, if you put it so it's void add triangle. It's a method there which takes a triangle T. Okay, and then the definition here doesn't really matter. So that's all the information you need to decide if the line should compile or not. Let's see. So over here, we know that add triangle is defined as a method in polygon collector. So this part is okay. But now we want to see if it is okay to actually pass T here. Okay, that's what we want to know. As I said before, if you want to do T here, you're basically just trying to, let me just call this T1. It's easier. So I say that's T1 and T1 over here. So we don't have any name clashes here. Okay. So now basically I'm trying to replace this one by T1. I'm basically doing the following assignments. I'm saying triangle T is assigned to T1. And should this assignment be allowed or not? Am I doing something wrong here? I said add rectangle, sorry, not add triangle. That's my bad. Let me do it again. So I think this part here should be add rectangle. Okay, add rectangle here. So now there's no need to call that T1, just T. Okay, add rectangle here. Okay, and then here, this will be rectangle R. Okay, so basically the assignment we are trying to see is rectangle R. So we are trying to replace R by T. Okay. Rectangle R is assigned to T. Okay, so we want to see if this assignment here is valid or not. So we know that for R here, the static type is simply just rectangle. And for T here, the static type is triangle over there. So now we are really asking if triangle is a descendant class of rectangle. It is not. Because triangle is here, rectangle is here, they have nothing to do with each other. Okay, that's why this line here will not compile. Okay, any question about here? Why this line doesn't compile? Again, you should really know that whenever you pass an argument here, it's really like you're trying to do an assignment to the parameter over here. Okay, and the same rule applies. Okay, let me just do it here. Okay, the line below does not compile. Okay, so it is as if we did the following assignments. Because at rectangle we have rectangle R is assigned to T. Okay, the static type of T, which is triangle, is not a descendant class of the static type of R, which is rectangle. That is why it doesn't compile. Okay, let's comment that out. Yeah, make sure you understand why this line doesn't compile. It's very important. Okay, after this, let's say we do let's say pc.add polygon. Now, if I say t, this will be okay, right? Because now the line below does compile. Let's say compiles. It is as if we did the following assignments. Okay, let me just leave some space here. So we'd say, because now add polygon, if you go back to polygon collector here, add polygon takes polygon P, right? So it's as if we did the assignment polygon P is assigned to T. So now we can say, apply the same pattern of arguments. The static type of T, which is triangle, is a descending class of the static type of P, which is polygon. So that's why this line here compiles. Okay, we add polygon P, and let's add polygon R as well. pc.add polygon R. So now I would like you to try the following instance of checks. If I say system.out.println, okay, I'll just put the expression here. Let's say pc.polygons at position 0, instance of polygon, okay, instance of rectangle, instance of triangle. And I want you to just copy and paste these 3 lines over here, but now I want you to change that to 1. Without running your Eclipse, think about what should be the output from there. Apparently, instance of is going to check to see if the dynamic type of the left-hand side is a descending class of the right-hand side, right? So now you have to know what's the dynamic type of PC.polygons at position 0. And what's the dynamic type for PC.polygons at position 1? Yeah, think about that and tell me your result without executing the code, of course. Give you a minute to think about it, and then we'll discuss. Okay, let's do step by step. In line number 42, what's the dynamic type of PC.polygons at index 0? Dynamic type. Triangle, agree? Since in line number 41, we try to add a triangle as the first one. Since there's a triangle, when I say triangle instance of polygon, I'm really asking if triangle is a descending class of polygon. It is, so that's true. Line number 43, the same dynamic type. So I'm asking if triangle is an instance of rectangle. It is not, because triangle has nothing to do with rectangle, so that's false. Line number 44, I'm asking if triangle is an instance of triangle. It is. It's a descending class of itself. So it should be true, false, true. Okay. It should be true, false, and true. Similar, so let's say 46. After line 45, we know that PC.polygons at position 1 should have the dynamic type rectangle, right? Because R has the dynamic type rectangle. So now rectangle instance of polygon should be true, right? Because that's the descending class of polygon. So true. Now rectangle instance of rectangle, true, right? The rectangle is the descending class of itself. Line number 48, rectangle instance of triangle should be false, right? Because rectangle is not a descending class of triangle. So that's what we predict. Let's see if we are wrong or right. True, false, true, 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 false. True, false, true, 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 false. Yes, that's what we got. Oh, let me run it again. Yeah, make sure you know for each one of them why it is the case. Okay, very important. Okay, so now let's do something else. So let's say now we would like to print out the area for each one of the polygons in the collector. Let's say print out the area of each one of the polygons in the also before each print out, identify if the polygon is a triangle or a rectangle. So somehow we want to use the instance of check to see if the polygon is a triangle or rectangle. Okay, we're going to do it together. Okay. And then we're going to see how the dynamic binding is going into play. Okay, let's do this. For integer I equals 0, I less than PC, the number of polygons, I plus plus. Okay, let's say here we say polygon P is assigned to new. Oh, sorry, not new. So here will be PC dot polygons at position I. Okay, maybe I cannot call that P. Let's say polygon. Just say polygon here. So now before I print out the area, oh, I can certainly do this. I can say system.out.println polygon.get area. So now dynamic binding is going to make sure if the dynamic type of polygon is actually triangle, it's going to print out the area of the triangle. Otherwise, it's going to print out the rectangle area. Okay? But now I want to identify to see if the polygon is a triangle or not. So now here I would say if polygon instance of a triangle, okay, say system.out.print area of triangle, else if polygon instance of rectangle. So this might be some new example you see how to use the instance of. It's actually quite useful rather than just before you do the cast. It can be very useful in other scenarios. Area of rectangle. Okay.
Just one question:
Mm-hmm.
Is this the only way to determine a thing's dynamic type?
You mean instance of?
Yeah.
Yes, that's the only way. Yes. Yeah. Yeah. So in this case, because we want to know the specific type of the dynamic type. But if you didn't want to know that, you simply want to print out the area. You simply don't need the instance of. You can call polygon like an area directly, and then dynamic binding is going to work under the hood.
So like you can use this in assignment, I think.
I think that's what you should use for the assignment 3. Yeah. I think for assignment 3, you should really try to apply the principle we talked today, and also how to use instance of. That's why I'm showing you some examples here. I wanted to make assignment 3 as straightforward as possible. So that's why I'm giving out the solution in the lab sessions. So try your best. Okay, so now let's see. Like if you run it, you're gonna have area of triangle. Oh, actually, rectangle. So let me say print rather than print line. Sorry. So now you can see that because we add a triangle first, so we can say area of triangle is 6, area of rectangle is 12, right? So the first polygon in the collector is a triangle, and the second polygon in the collector is a rectangle. Okay. And one thing to note over here, I'll write it here. Due to dynamic binding, depending on the dynamic type of polygon, the correct version of get area will be called. When I say correct, I mean either the version in the triangle or the version in rectangle. That's about what I want to say for the collector. Okay. We'll actually do a little bit more there in the slides. So now it's binding. Okay. And we have 10 minutes to do the constructor. Okay, polygon constructor. Okay, that'll be quick. Any questions about the collector here? Okay. I hope this stuff is getting more and more interesting for you, right? Just rather than just leave the analysis loose in the first half of the course. So you got classes, you got objects, inheritance, polymorphism, and next week you're gonna get recursion, generics. You got lots of stuff to play in the final exam. Did you realize you got 150 minutes for the final? Yeah, it's 2.5 hours. And of course, they're gonna keep you very busy. Maybe 2 hours. Okay. Hopefully, everybody can finish within 2 hours. Okay, let's see how we can do constructor quickly, and then we're done. So one thing I would suggest, although we are now doing this example using abstract classes, but I think for Friday's quiz, I'm going to ask you something similar, because here, when you pass arguments for the methods and how you get return values for the methods, they're kind of related. So I would suggest you study this example as well. Okay, so let's now do quickly a polygon constructor. Can we just create a new class over here? Polygon constructor. Okay, main, finish. Oh, sorry, no main. Sorry about that. Get rid of main. Just a class. Okay, so now for the constructor here, we have just one method to play with. So let's say we have a method called getPolygon. Polygon is going to return a polygon, and then get polygon. And then the parameter is going to be an array of double sides. Depending on how many elements you have in the array, we're going to create either a triangle or a rectangle. You can say the static type of the return value of get polygon is polygon. That's what we declare. So now let's say polygon p. That's what we eventually going to return p. Let's say initially just null. Bless you. Okay, let's see how we can do the return. Depending on the length of the sides, if sides dot length equals 3, in that case we want a triangle. So we can say P is assigned to new triangle. So sides 0, sides 1, sides 2. So now we change the dynamic type of the returned value P to be triangle. So you can see the return value is simply P. It was declared to be of polygon static type. So now we say the dynamic type is triangle. Okay, else if we say sides dot length equals 4. So now we change the dynamic type of the return value P to be rectangle. How do we do that? So now we say P is assigned to new rectangle and the width and the length. You can say sides 0, sides 1. Let's say. So there are two possible return. There are two possible dynamic types for the return value P. Either it can be a triangle or it can be a rectangle. It will be a triangle if we execute line number 12. It will be a rectangle if we execute line number 17. Okay, two possibilities. Depending on what's the length of the array that you pass to call the method. Let's see. Okay. So now let's go to the polygon tester over here. Let's try to test that. Okay. Okay. So now let's say we want to do let's do a rectangle first. Double rectangle sides is simply an array of size 4. 3, 4, 3, 4. So 3 is the width and 4 is the length, let's say. Double array. Okay, so now let's first of all let's create also a polygon constructor objects. Oh, actually I used the PC already, right? Let's say pcon. Okay. New polygon constructor here. Okay, let's do one thing here. Let's say, let me just define something like this. Polygon, let's say P2. Okay? If I say P2 is assigned to pcon dot get polygon okay, there are already many things we can say. Okay, so now I want to ask you this: why does line 70 compile? Again, we're going to see the static type. So we know that the static type of the left-hand side P2 is polygon. That one's easy. But now, what's the static type of pcon that get polygon? I will show you the definition for that. So you can see pcon over here is a polygon constructor class objects, right? And when you see get polygon, you can go to the polygon constructor here. You can see get polygon here returns a polygon. So the static type should be polygon. Okay. So if you go back to tester here, so that's why this expression here has the static type polygon. And polygon is a descending class of polygon itself. You follow? Follow? Yeah? Okay. Okay, let's write it down. P2 has static type polygon. And you can say the get polygon method in polygon constructor has the let me say this: the return value of the okay, that's better to say that. Oops. So the return value of the get polygon method in polygon constructor has static type polygon. Okay, because if you see the declaration there is polygon as a return type. So now polygon is a descending class of itself. That's why that line compiles. On the other hand, if I try this, if I remember we added, oh, actually, let's try this. Okay, if I say rectangle R2 is assigned to polygon constructor.get polygon. However, this line here will not compile. Although we know that pcon.get polygon is going to return a rectangle object. But remember, that's a dynamic type, which Java compiler knows nothing about. So now this line here does not compile because the static type of pcon.get polygon is still polygon. And polygon is not a descending class of rectangle. That's why. Okay? You can do a cast if you like, which we'll do in a moment. Okay, so the line below does not compile because the static type of pcon.get polygon is polygon, which is not a descending class of the static type of R2, which is polygon. Oh, sorry, rectangle. You should really know why it doesn't compile. Okay, let me comment this out for now. Okay, so now let's go back to line number 74. So P2 is going to be a polygon, so we know that this line compiles. So let's try the following. If you say system.out.println, if you say P2 instance of rectangle, system.out.println P2 instance of triangle. Okay, let's try one more. And then system.out.println, this will be polygon. Okay, what should be the results from lines 75, 76, and 77? What should be the output? So now, since we're doing instance of, so it depends on what's the dynamic type. It compiles, but what's going to be the runtime results? So now you have to see what's really the object that's being returned from get polygon when you have an array of size 4. As we know, if you go to the polygon constructor there, you can see that over there, in the case where the length is 4, we're going to return a rectangle. In that case, the dynamic type will be rectangle. Okay, that's why you have rectangle instance of polygon, that's true. Rectangle instance of rectangle, true. Rectangle instance of triangle, false. Okay, so now one thing to note, yeah. The dynamic type of P2 is rectangle because rectangle size dot length is equal to 4. Okay, and then you actually see why the rectangle objects returned. Okay, so now you're going to see that this will be true, this will be true, and this will be false. Let's try that. Okay, true, true, and false. Okay, finally, let's try one more time. One more thing. Okay. So now we know that this line here will not compile. How can we make it compile? So now we can say if R2 dot R2, let's say this. If pcon.get polygon, so this is what's returned from rectangle sides over here. If there happens to be an instance of rectangle. Okay, so we are saying that if this expression here has the dynamic type rectangle. Then we can cast that into rectangle. In that case, we can do the following. And now we can say rectangle R2 is assigned to rectangle, and then we can now cast this expression here into that. And then we can say system.out.println rectangle area plus R2 dot the area. Yeah, this line, this part here is a little bit more challenging. So basically, we're trying to say, based on the object that's returned by getPolygon. So in this case, it's going to return back to you a rectangle object. In that case, rectangle, the instance of rectangle will give you true. So that's why you execute this cast and also to print out the area for the rectangle. Of course, because R2 has the dynamic type rectangle, so it's going to call the version of the area as defined in the rectangle class. Okay, that's about what I want to say about the case study we did in the class today. Quite a bit to study, so I would say try to go over the comments I wrote over here. So I think I just gotta think about it. And come to the tutorial session on Wednesday. Oh, by the way, I think that you received an email, right? The chair wants to see you guys. So maybe, yeah. So maybe I'll send an email. Maybe let's not do the tutorial session Wednesday because the chair wouldn't be too happy if you guys come to my session but not his, right? But you might go to his anyway. But let's do a tutorial session at another time, or you can ask me later in the office hour. Okay, if you have no questions, we'll stop here.